All right. So no, is everybody else okay? You guys doing all right? Yes.
For the textbook online for WebAssign, you still have to pay for it, right? Or no?
Yeah, you have to pay for WebAssign, but WebAssign comes with an ebook.
What if it's asking you to pay for the ebook?
Pay for the ebook.
Yeah.
You pay for WebAssign access, and then you enroll in WebAssign, and the account you enroll into has an ebook attached to it. So if you could, at some point, just send me a screenshot or something.
Because it's asking me to pay like $200 something for the ebook, which I don't know what to do if I
Don't do that.
Yeah.
That's 2 semesters or one? Even that's like for 2 semesters.
I'll send you a screenshot.
Okay. There are other people, several of you guys signed up fine for WebAssign, and it didn't request extra money from you, I'm hoping.
Make sure you're going for Grossmont too.
Yeah.
Let us sign Grossmont.
All right. Okay. I see a lot of empty seats, makes me really concerned. I officially have 49 students. There's one more. Two. Oh, yeah. 4, 6, 2 more. 34, 35. So I'm only missing like 14. Okay. Yeah. It's a correspondence course, right, Jeff? Anybody else who wasn't here Monday? Oh yeah, okay. But you got stuff for me, right? Yeah. And of course you and I talked already. Anybody else who wasn't here Monday? Okay. Oh, that's right. But did I send you stuff and all that? Or no.
No, we email back and forth.
Yeah, you have access now. You're good. Okay.
I'll have access by the end of the day.
Okay. All right. So, did anyone have a chance to attempt Chapter 1 homework? Are there any questions from that?
So many, lots.
Hit me.
How do you algebraically find the range of a function?
Ooh, very good question. Okay. Oh, let me set. Are you going? I think you're going. Yes. Okay. These guys. Oh, good. All right. Oh, let me do this. Sorry. I just want that to go away. And to do that, I have to make every other light dim. This is interesting. Very interesting. Did you try turning it off and turning it back on again, Jeff? Yes. I can do it old school. See what happens. So let me do this. That's just for that. That's the power.
There you go.
Huh?
Something happened right before you.
Oh, of course. Of course. But would have just waited one more second. Alright. See if he works. Get him on now. Oh, I miss the days of chalkboards. Okay. Ooh, ooh. All right, some monitors are working. That's neat. Okay. Okay, we got 2 monitors working. That's fine. Here at Grossmont College, we spare every expense. Sorry. So your question was, how do you find the range of a function? So, for example, real quick, just to remind us, how would I find the domain of this? I know the question is range, but very quickly, how would I find the domain of this? Sorry, go ahead. No. No, it's the square root, right? Okay, so real quick, what's the domain? All the x values you're allowed to use, right? All x values that have a valid output. Yes, it's another way to think of it. What's the restriction on a function like this? Is there a restriction? Are there certain things that could happen that would freak this function out? Can't be negative, right? So in English, I would say the inside can't be negative. It's always nice to start. Inside can't be negative. What's another way to say can't be negative? Has to be at least. If you can't be negative, you have to be at least zero. Not greater than zero, at least zero. Because is zero negative? Okay, so it's good. Square root of 0 is 0. So the inside has to be at least 0. Now listen, everything I'm telling you right now, if I give you a function and I say what's the domain, if you can say in English what needs to happen, and then write what you just said in Mathish, solve it, you're done. It's almost too nice to believe. But that's just a reminder that English and math are more closely related than you realize. Okay. So the inside can't be negative. Inside must be at least 0. What's the inside? 3x plus 7. At least 0. How do I do that mathematically? Greater than or equal to 0, yes. And then how do you solve that? Subtract 7. Divide by 3. Yes, is that okay? I skipped a step there, but it's just, algebra. So then you can graph and all kind of bullshit, but that would be the domain. Okay. And you're sitting there very patiently going, I asked about the range. What do we know about the square root function? We basically just figured out as we talked about domain. If it hasn't been shifted around up or down, what's the smallest output of a square root function? 0. And where does it go from there? Up. So as long as it hasn't been flipped or moved up and down, can anyone tell me what translations have actually happened? There's a lot of ideas that we could talk about with this problem. I love it. Has this function been moved up or down? Nope. What would make it move up or down? If there was a plus or minus outside, because I can move that with the letter with the y over here. If it's with the x, it moves left and right. If it's outside, it moves up or down. It's crazy. So this would be a shift and a contraction in the x direction. So did it move up or down? No. Did it flip? No. So it starts. What's the range then? What's the lowest output? And what's the highest output? Infinity. Is that okay? So a lot of the range questions,
You don't actually have to.
there are problems where you could do some algebra to it, but to be really honest, fundamentally most range questions rely on you knowing what the function looks like if you graph it. Yes? So the range would be 0 to infinity. I keep looking at, I'm gonna make those monitors work.
So if I'm not familiar, just by looking at a function, if I'm not familiar with like what shape of graph that would make, I can like use a graphing calculator.
Yes. And I should have worn the shirt I wore yesterday today because it was my little dude dancing all the shapes of the graphs of things. You have to know the shapes of graphs. Can you guys in the air do a natural log? Can you do a natural log graph? What would it look like? Or just any log? Got a heartbeat. I got an exponential, looks like. What you got? Oh, that's neat. That's more like a parametric. All right, so so a logarithm goes like this. It's an exponential, but it's the inverse of an exponential. Yes? Okay. So logarithm has an asymptote at 0.
So the shapes of certain functions is something you just memorize.
Yeah. So what's the range of a natural log then?
0 to
Asymptote here, and then it just keeps going up forever. The range. What's the smallest output? The infinity. What's the highest output? It goes up to infinity, yeah. Negative infinity to infinity. So a natural log, or log, looks like this. asymptote here. So it goes down to negative infinity, and it's eventually, it's basically the slowest growing function once you're out here. But it will go to infinity eventually. Do you have a specific question? I think it was.
I was just looking at the first.
Was that a square root of like a?
Homework problem?
Sure.
It was fx equals 2 divided by parentheses 3x minus 1.
Oh. Okay. Can you tell me the domain?
So for the domain, I got negative infinity to 1/3.
Yes. So real quick, what can't happen? The bottom can't be 0. 3x minus 1 now equals 0. If you solve it, you get x can't be 1/3. Why does that tell me domain?
Because if the bottom.
No. More basic than that. What is domain related to what variable?
X.
All right. So I know domain because this is a function of x. And remind me, what is this? What did this replace from algebra? Y. One way to get this guy's range, and this is so cool. All right, let me stop for a second. I've actually thrown a lot at you. With it, you're like, I asked one question. What's this guy doing? Is everybody semi with me here? Everything I'm talking about right now is important. Not always. I say weird shit all the time. That's not important. This stuff is important. This stuff is going to come up every now and again. So if any of this makes 0 sense, you got to let me know. It's pretty cool with the domain, you can't include 1/3. Because that would make the bottom 0.
Yeah.
Okay. What if this was x equals business with y? Couldn't I then determine the range the same way? If this was a y and not an x, that would actually reference the range, wouldn't it? It would tell me what y couldn't be. So what you could do, God, I keep looking at that. Bring y back. Now solve for x, which is a really, really bodacious algebra refresher. How do you solve for x? Where is x? That sucks. What's the first thing I want to do then? Multiply 3x minus 1, both sides, right? That lifts the thing I'm trying to solve for out of the bottom. Because if the thing I'm trying to solve for is on the bottom, that's a problem. Here's a really cool thing about algebra. What is 10 divided by 2? And what's 10 divided by 5?
2.
Do you see how I can just switch these? If I divide a whole thing by any chunk, it's the other chunk. Does that make sense? So I can just multiply this up, divide this down. These just switch. Do you guys see that? So I don't have a problem with shortcuts as long as it's based on your understanding of why the shortcut works. So that's a beautiful little quick algebraic shortcut.
So then, how do you get an actual number for y if you don't know what x is?
No. Did we know shit up here? And you told me the domain, didn't you?
Yes.
Okay. And you didn't know anything, right? Okay, keep going. Do I have it solved for x yet?
No.
No, okay. How do I solve for x? That's true. What do I do next? Add 1. Divide by 3, yes? Okay, let me stop for a minute. Is that cool? I added 1 and then I divided each piece by 3.
Yeah.
What can y not be? 0. So what's the range? 9 infinity to 0, 0 to infinity. The exact same reasoning you did here. Yes, the bottom can't be 0, x can't be 1/3. The bottom can't be 0, y can't be 0. So there's going to be an asymptote at 0.
Oh, I see.
Let me stop for a minute. Do you guys see that? That is trippy. You guys don't normally get shown that. But anything I could determine because it solves for y, I could determine the other thing for if I solve it for x. Okay, maybe. Do you guys remember how to determine a horizontal asymptote?
Set the numerator equals to 0.
No. That would be finding the x-intercepts. Look at this function. Where's the degree bigger? What's the degree of the bottom? Yeah, what's the degree on the bottom? First degree. What's the degree of the top?
0.
0th degree. So where's the degree bigger?
On the bottom.
As x gets really big, what does this whole thing do? Goes to 2 divided by big as all hell is 2 divided by 1 is 2. 2 divided by 18 billion to the billionth power is really stupid small, yes? Are you with me? Okay, so as x gets really big, this whole thing gets really small and it goes to 0. So that's the asymptote at 0. Is that cool? And that jibes with, we just said y can't be 0. Okay, maybe. What's important right now is all the little things I'm bringing up, asymptotes and shapes of graphs and so forth, you try to catch what you've forgotten, because now's the time to bring it up. It's too bad you gotta leave, because you're one of the few that have questions, apparently. No? It's okay. Sure. Sure. Anything from what we just did, or any other questions on problems? Okay. I really want to make this clear, and hopefully, I always worry if I'm not making myself approachable. I live off of questions. My personal hell is a very quiet class. I will still do a good job. I'll still teach. I'll do all that stuff. But I love discussion. Right? Yes.
Can you determine whether a function's odd or even?
Okay, cool. So here's what's funny about the words we've chosen for those symmetries. Does anyone remember anything about even symmetry? Or odd symmetry? Does either one of those sound familiar? Yes? What do you remember about even?
Even is like a parabola.
Yes.
X-axis.
And what's really funny is even has a symmetry like a parabola does. And what's the power for a parabola on the function? Yes, even number. Yes? So even symmetry looks like a parabola, x squared. Odd symmetry has the same idea as a cube. Okay. So let me make that more nuts and bolts, more practical. You're like, that's great. What do I do with that, Jeff? If they're asking me which one of these a function has, even symmetry is like an x squared. And what that technically means, what do I get when I square 2? What do I get when I square 2? Holy shit. And what do I get when I square negative 2? Holy shit. Okay. To have even symmetry, when you plug in a value and you plug in the negative of that value, you get the same output. Is that cool? That would mean the mirror is on the y-axis. That's what even symmetry means. So how do I make that, I should have put you somewhere else. How do I make that more actionable? If I'm given a function, plug negative x in. And if that is the same as it was with the positive in there, it's got even symmetry.
Can you repeat that again?
Yes, in fact, let's do an example. I'm given this function. And they ask me, is this even or odd or neither symmetry? I immediately plug a negative x in. Because what's the idea of even symmetry? If I plug an x in and I plug a negative x in, the outputs have to be the same. So can you guys go ahead and plug a negative x in? Go ahead, plug it in. Plug it in. So if you plug a negative x in, what is negative x squared? X squared is a negative x. What's negative x to the 4th power? X to the 4th power. Is that the same as what it used to be? So what kind of symmetry does this? Even. Cool. There. Now what really kicks ass is how do you test for odd symmetry? So let's talk about odd symmetry. You test for odd symmetry the same way, it just has to have a different output. So for odd symmetry, odd is cool because then it's like x cubed. X cubed looks like a parabola where half of it fell out. So it had a really bad or a really good night. So it's like a parabola, half of it fell out. Yes? This way, that way, whatever. You with me? Or one of my colleagues calls it the giraffe graph because it looks like a giraffe, but I used to joke because it looks like a giraffe that lost its front legs, so it's going to fall over. But it's okay. So what's the aspect of this? What's 2 cubed? 8. What's negative 2 cubed? Negative 8. Therefore, when I plug a negative x in, I should get exactly the negative of what the function was in the first place. So here, let's do a little trick. So if I'm given this function, what do I get when I plug a negative x in? Do you guys remember? All right, think about this. What's this? All right. If you're one of those students who doesn't remember the trig or maybe didn't really do much of it or never did any of it, then okay, you're continuing to work with me hopefully. Do you guys remember what sine of 45 degrees is? Yes.
2 square root over 2.
Just root 2 over 2.
Yeah.
Why is it positive? First quadrant, which it's y is positive. Sine likes y, cosine likes x. SOHCAHTOA sucks. I wish we never taught the damn thing. Yes? If you just know sine likes y, cosine likes x, everything makes sense. Now, what about sine of negative 45 degrees? Where am I now? What quadrant would that be? Fourth quadrant. Down here, yes? So the output is the same number, just what sign will it have? Negative. So when I plug a negative x in, I'm going to get negative of what I would have gotten before. So what kind of function is sine? What kind of symmetry does it have? Odd symmetry. And what's the sine function look like? Where does it start? What sign is 0? 0. So it goes like this. And it goes like this, yes? So it looks sort of cubish if you really squint. It doesn't look like a cube. But it does have that symmetry through the origin. It's definitely not even. Cosine looks like an octopus, yes? I don't know if anybody agrees. It's a little bit like an octopus. We just go this far. That is definitely like a down parabola at first, but then it continues having that reflection across the y-axis, I guess, yes? If I just move that by 90 degrees, that's sine, now it's odd symmetry. Maybe. Maybe. Screw you. So either you know the graph of the function, you know what the answer is, or you can just plug a negative x in. If the answer is the same as it was, even. If the answer is different, the negative of what it was, odd. If it's neither one of those two, neither. Because does every function have even or odd symmetry? No. If I just move a parabola over, it's got neither symmetry now. Because it's not symmetric to the y-axis, it's not symmetric to the origin. Are you guys at all with me? Okay. Like some of you guys are like, I would never play poker with you. Okay.
I welcome that.
Good. Anything else? Did that help? Whoever asked the question, is that okay? Yes? No? I suck. Did you ask that question? Who asked the question? You did. Does that help? Yes, okay. All right, so anything else from homework stuff? Do you start to understand it's a really, really, really good idea to attempt the homework, because I always carve out time at the beginning of the next class to discuss it. And here's a really neat thing. Chapter 1, I'm counting it as we finished it, even though there's still a few things you kind of have to review on your own. So when should you really have chapter 1 ready to turn in? Monday. If you don't, is that horrible? No. You with me? It just means you're a little behind from where you should be. If you really need to, you can leave chapter 1 and do some chapter 2 stuff, and then come back to chapter 1 as you have time to review. Are you with me? Totally do that, that's fine. You have until the test date. After that's when it's late. Okay. Yes?
Number 4 of the homework, it's related to
Oh yeah. Okay. And I love it because
100% if I got it right.
students are like, all right, you want me to sketch the yield for fertilizer? What class is this? This is agricultural class. So real quick, guys, if you don't put any fertilizer at all, are you gonna get a lot of apples out of the apple tree? No, you might get some, because maybe there's some natural resources in whatever dirt you put the tree into, yes. But maybe not much. If you put some fertilizer down, will things get better? Can you imagine what the graph would look like of fertilizer versus yield? Can you start to see it? Now, if you say this, why is that insane? You just draw a straight line. Because then you're like, I can get infinite yield. I just need these cows to keep shit. Okay. No, that's not gonna work. What's gonna happen is just start, can you imagine somebody just going and say, just plopping up like tons of freaking fertilizer, it goes like weird brown snow, just keeps going up. What's that tree eventually gonna do? Just keep putting more and more fertilizer. You're like, more apples. No, the tree's gonna freaking die, yes. So, can you imagine what that graph looks like? As you increase the amount of fertilizer, what's your number of apples? It didn't say apple, but I'm just saying apple. Number of apples is gonna go up. And then what's gonna happen if you keep putting more and more fertilizer? At some point it's gonna, yeah, okay, I basically gave the answer right now. So you don't have to be an expert on agriculture. It's just really, can you take a physical idea and give it to me in graph form? There's no exact answer, but there's definitely wrong answers. If you go negative yield, then I'm like, is it an apple black hole? If I have an apple and I get too close, does my apple disappear? So certain things about the graph would mean you're wrong.
Yeah, I guess that's where my question was. It's like, it doesn't go on forever. It's going to end.
Yeah, it's gonna
start from 0 and then go back to 0 probably.
That's one way to do it.
Okay.
You could say at some point it's just gonna actually kill the tree. Because if you get it high enough, it ain't getting any sunlight. Yeah. Alright. Is that better? So that's a little bit of a tricky question. Anything else? So right now, if you're like, man, I didn't even start that homework. All right, I'm gonna start the damn homework. All right. You've got tutors, you've got the SISL. Does everybody understand about how the SISL works? All right, we're actually gonna go on the field trip towards the end of class. And we're gonna end in the SISL because then my SISL hour starts, so I'll be in there. So I had like 4 students come with me Monday and just started doing some homework right there. I actually did some trig review with them too. So right after class, 3 o'clock, I'm in the SISL until 4:30. So if you wanted to like work on whatever, it's a really good idea to do homework immediately after we talk about it, right? Because then it's fresh in your brain. Yes? 3. Yes. Which is 1 more than people doing textbook. They get 2. Yeah. So I try to make it as balanced as I could between the 2. I try. I hate all my homework, but some people get stuff out of it, so I'm okay with it. Okay.
The only thing with the online stuff is sometimes the system wants it inputted a certain way.
That is a huge thing. You have the right answer, you just put a semicolon or whatever. You put your 1/7 instead of this over 7. Rest. So as a student, you feel like you got the whole damn thing wrong when you actually got the right answer. So feel free, there's like an ask my instructor button. Feel like I know I got this right. Just hit that button and say, hey man, I can see all your past attempts. And I've given people points because I'm like, yeah, you got it right. Just the stupid system thought it was wrong. Okay. That is a huge reason. Not the only reason, but a huge reason I hate online homework. Yeah. As a human, I can see better what you're trying to do. Anything else? Okay. I wanted to double check. Yeah, we did quite a bit. That's right. We talked about laws of logs. We talked about some trig stuff. We talked about, okay. Let's talk about this real quick. Inverses. How do you guys feel about inverse functions? Anybody have opinions about inverse functions? Please forgive me. Let me try one thing. You guys consider that. I'm going to try to see if I can't wake up these other monitors. Oh, I should have waited a little bit. Now watch this. I will. Now those will come on, and these won't. How did I know? Right? Is anybody understanding the beautiful irony of what just happened?
I don't understand how these things keep getting messed up.
I know. They find a way.
Interactivity is not the same as function.
I should have left well enough alone.
Oh,
Alright, these came back, and that one came back. Okay, I'm stopping there. Screw it. I'm up one monitor.
People on the left side of the room,
I'm not
sorry.
a gambler. I can walk away. Okay. Everybody can see something, yes? If you see something, yay. Okay. So let me ask you this then. So what does an inverse function mean? What does that mean? What does it mean to talk about an inverse function?
X and a Y swap.
Okay, that's how you find an inverse function. I love it. So effectively, an inverse function is a function that does the opposite operations that the original function did. So a very easy example, if my function is x plus 5, my inverse function is x minus 5. All right, so they're not always going to be that easy, of course. In fact, some inverse functions are exceptionally freaky. And some functions don't have an inverse. So let's start here. How can I tell if a function has an inverse? You guys remember? How do you tell if a function, if a graph is of a function? How do you check to see if it's a function? What graphical test can you apply?
Vertical line.
Vertical line test. Because the definition of a function is related to the movie Highlander. There can only be one. So for every input, there can only be one output. So if I draw a vertical line and it goes through the function more than once, that means that x value had two outputs. It's like me saying, where were you in the night of Wednesday, July 16th at 5 p.m.? And you say, well, I was at the library and I was, who were you? What? What technology do you have access to? No, you were in one place. So for an inquiry, your answer could only have one option. What size shoe are you wearing on your left foot? If you tell me two numbers, I'm like, who are you? Why do you have two shoes on your foot? What's going on? You with me? Okay. To tell if it's an inverse function, not only does every input have to have only one output, but every output must also correspond to only one input. So let me show you. Is this a function? Hi. A little parabola, poor little guy. Is that a function? Why? It passes the
Vertical line test.
It passes the volt. Every x has only one y. When I square 2, I get 4. Does every output have only one input that it came from? What do I square to get 4? 4? Negative 2. So does every output have only one place that it came from? No. The output of 4 came from 2 or negative 2. So I always think about it like a detective. Can I figure out who murdered somebody if I know that when you square it, you get 4? It could have been 2 or negative 2. I don't know. Does that make any sense? I like the idea of because we're trying to work backwards then. So this is not what we call, does this sound familiar, one-to-one? So it is a function, but it's not a one-to-one function. And one-to-one is probably one of the better naming things that math people have trouble naming things. You've lived through this. But one-to-one is beautiful. Not only does every x only go to one y, but every y only goes to one x. 1 to 1. So if I know where it ended, I know where it started. That's the idea of like a detective. If I know it's this, all I know was this guy, right? Maybe. Is that right? So of course, most detective cases are not one-to-one because we've got to gather a lot of clues. Yes?
I was going to suggest that you probably just like take like a line, draw it across the side, and if you can't draw it, and you can't hit two like points anywhere, then it's one-to-one function.
Beautiful. So the really funny thing is the vertical line test tells me if it's a function. The horizontal line test would mean this y. Does this y have more than one place it comes from? Yes, it does. Yes? A vertical line test, is it a function? Horizontal line test, is it one-to-one? Does it have an inverse? A lot. Good. Okay. So to be in an inverse, to have an inverse, so to be a function, you need to pass the volt. To have an inverse, you have to pass the volt. Vertical line test, horizontal line test. Does this sound familiar to anybody? Some of you guys? Okay. Now, I'm going a little fast because this is a bit of a review, but definitely slow me down if you need to. Do you guys remember? So can you tell me if this very simple function, once I get it drawn, you're like, I can't tell you shit about it yet. I know. Give me a moment.
So for it to be inverse, it has to pass both the vertical line test.
Yeah, to be a function that has an inverse, it has to pass the volt and the volt.
Okay.
Okay, so this very simple function here, very simple, you still can't draw it, Jeff. Sorry. Is that a function? I just said it was, so it must be. Well, why is it a function? It why does it have an inverse? Why is it 1-to-1? Passes the horizontal. Yes? Okay. Here's the neat thing. I don't even know what the function is. Do you know what that function is? Anybody realize it would have to be like a piecewise function? You guys remember piecewise? Not pennywise, not we all float, but piecewise as we define in pieces. Yes. Okay. Don't worry about that. We're not going to get there yet. Can you tell me what points this goes through? Let me call this F. What points does F go through? What point is this trying to be back here? Let me make these big. Yeah, -3, -3, yes? What else? -1, 0. 2, 1. 3, 4. So here's the neat thing. The inverse function is supposed to undo whatever the original function did. What did this function do to 3? If I had an input of 3, what did it do to it? Made it become, you can do it. When the input was 3, what did it give me? 4. I don't even know what the function is, correct? I don't need to, because I can see. When somebody shoved a 3 in the poor guy, it gave us a 4, yes? So what's the inverse function's job? If I shove a 4 into it, it's going to give me a 3 back. It's going to undo it. So I have a stretchy function, and then I put it into the other machine, and it's like, right? And then I keep going back and forth, and that's the military. Now, that's something that could be the military. Move this over here. Now move it back. Shit. So what points does my inverse function go through? Here's the beautiful thing. You just flip the x and y. Because now the output becomes the input becomes the output. Does that make sense? Because that's what the hell it's supposed to do. When you input the output of the original function, the inverse gives you the original input. That's what it does. So of course, and so many guys, somebody said switch the x and y, you did. And that's how you algebraically find the inverse. Thankfully, it's also how you graphically find the inverse. Now, can you guys take a minute and plot those points? Yes, on the graph that you very obviously made in your notes, this graph. Go ahead and graph those points we just came up with for the inverse. Plot those points, I should say. Do I have to give myself one more? Yes. So of course one of them is here. Then it goes 0, -1, 1, 2, 4, 3. Do you guys notice anything interesting? If my scale was better, it would be even better, but if you were going to put something down that was a mirror between the black and the blue line, where would that mirror be? Yes, straight through. In fact, it would be the y equals x line, which makes sense because we switched the y and x. Has anybody ever heard the Nazca lines down in Peru? Yes? Whenever I do this, it looks like a Nazca line at the end. Yes? There's a spider and there's a thing, and it's neat. By the way, real quick, the Nazca lines were these lines that only make sense when you're way high up and you're like, how did these people millions, thousands of years ago do this? Sorry, it's not going to be on the test. You can look it up if you want to. It's called Nazca lines. It used to be a Peruvian restaurant that I really loved. It was called the Nazca Cafe or something like that, and they closed that. It was sad. Okay. None of that is important. I'm sorry. Is that coming back? Is that all right? So if I give you a function, what do you got, Jeff? I don't know, man. How would I find the inverse function algebraically? I would bring y back. Stay with me now. Now tell me this, how did we find the inverse graphically? How did we find the inverse graphically? Switch x and y. So how do we find the inverse algebraically? Switch x and y. So I always do this for myself because I'm weird. I draw a little line because what I just did right now, I didn't do an algebraic manipulation. I applied an idea, right? Oh. Sure. Yes? Can you guys, this is sort of familiar, this is even better than what we did earlier. Can you solve for y? How would you solve for y? What would you do? Multiply by 3, because I like to kill my fractions if I can. Get out of there, Jeff. Try again. All right, 3 dies. And then, of course, I add 7 and then divide by 2. So this is officially F inverse. Wow, this is as far out as it goes. What's the first thing this does to an input? If I put a number in for x, what's the first thing you would do to it? You can do it. If I put a number in for x, what's the very first thing you would do to it? Double it, yes? What's the very last thing you do here? Divide by 2. Do you see how it's the opposite operation in the opposite order? That's the inverse function. What do you think would happen if I took this entire function and I shoved it in here? Made a little turducken of functions. They would kill each other. In fact, you do this all the time. Here, how would you solve this? How would you solve this? What would you do to both sides? If I wanted only the real answer, what would you do to both sides? You could do it. Cube root. You apply the inverse function. Why did you apply the inverse function? Because the function that's here, if I apply the inverse function, what do they do to each other? Kill each other. Yeah, there you go. So if I put one function into its inverse or vice versa, they will kill each other. The answer will be x. Just like we got there. What's the answer for the cube root of x cubed? I'm sorry, it doesn't matter where you look. I just point at what I can see. X. No. The answer, so the cube root of x cubed is x. Because the operations killed each other. Okay, maybe. Did it a little quickly. This should be a review. If you forgot, it's okay. All right.
Well, one question. So that
Yes.
would be a good way to check to see if your answer is right?
Yeah, totally. If you think you got the inverse, you could take, and you got time, you can plug what you got into the original and see if you just get x. Yeah. So here's what I'm saying. If I took this and shoved it into him, so it'd be 3 times this, yes? Because what does a function do? A function is very single-minded. It just says whatever you put in me, just put it into me. What would happen immediately? 3's cancel. What happens next? 7's cancel. What happens next? 2's cancel. What's the answer? X. So everything that was done to x is undone. That's it. Okay. Yes, sir.
So in general, you come up with an x straight x equals y line, right? You,
Oh.
yeah.
What do you mean come up with it?
I mean, when you plug a function into its inverse, what would it look like on a line?
No.
Or would it?
That doesn't, your question doesn't quite mean anything because what equals x? F inverse of f. Not y equals x. Y doesn't equal x. Just what do I get when I plug the function into the inverse? I get x. You with me? It's not y equals x. Yes? Because, all right. Do you see how this is where I started? Yes? Yeah, so what I did was I plugged f into f inverse, yes? And if I just do that symbolically, what do these do to each other? So of course the answer is x. Because the two functions, the function and its inverse, kill each other. But it's not y. F of x is y, so f inverse of f of x is not y. Okay. Okay. All right. Before I get into chapter 2 again, any other questions? Okay, here. So you guys are in mine. So if you haven't started chapter 1 homework, do it. Feel free to email me if you can't come to any office hours. The worst way to tutor is over email, but it's still better than not. Yes? So if you're like, I can't do number whatever, here's a screenshot of what I did, or here's a picture of what I can help you. Yes? Now I hope to God I don't get 30 emails. You can do it, it's okay. Can anybody remind me how you find the slope of a line in algebra? I like it. How do you find those two things? So if I would have said, what is the idea of the slope in algebra? That's how much a function rises versus how much it runs, yes? And that actually is a physical idea. If I'm on flat ground, I'm running a lot, but am I rising or falling? Hopefully not. If I am, that's a run. You know, leaning tower of math stuff. All right. Yes? Okay. So how do I find the rise and the run? Everybody remember rise over run? All right. Here's the neat thing. Here's a bit of a rhyme. When I rise, which variable changes? The y's. Rise, y's. Run is the other one. Yes? Still rise. Sorry. So what was the formula for slope? In fact, what was the letter for slope? M. Remember mx plus b? Okay. How did I find m? What did I have to be given to find the slope? 2 points. Is everybody with me? So that's what I wanted to get to. In algebra, to find the slope, I must be given 2 points. Is everybody with me? So this is one reason why I like to do chapter 2 in a different order than the book. Because I like to get the idea of what we're doing down first, and the book sort of doesn't do that. So I disagree. So we're motivated for what we do in section 2.1. So in algebra, I can find the slope of a line by getting 2 points that are on the line. What we do in calculus, it's really trippy. And this is why I feel a lot of pressure when I teach calculus. I love calculus. But I don't tell students until you're in calculus, I don't tell anybody this. Calculus is where math starts. Everything you've done has been getting ready for calculus. Once you take calculus and you do anything else after this, you're like, how did I do anything before I knew calculus? We learned 2 things in this class, 2 main ideas. And we're about to talk about the one sub-idea that leads to the first idea. What we try to do in calculus, what calculus wants to happen, and humans are like, all right, calculus, you're drunk, go home. It wants to know the slope at a point for a non-linear function. So if I have a function like this, and I want to know what the slope is right there. Can anyone tell me anything about that slope that would be true right at that point? Imagine you're on the roller coaster. What's the slope if you're doing this? Negative. Slope if you're doing this. Slope if you're doing this. And questioning why you got on this thing. It's 0, yes? What's true about the slope at the point where I indicated? Positive. You're going up, correct? Does any of us know how to get what that slope is? Even if I gave you what the point was, why could you not figure out the slope? Because in algebra, which is all you know coming into this, what do you need to figure out the slope? Another frickin' point, yes? Okay, now you understand how algebra is looking like calculus, like you're drunk. What do you mean 1 point? So everybody kind of, this is the central issue that we need to figure out. Why is this so important? Because then I know how quickly something is moving at a point, at a time, not over a period of time. Isn't it more important if I'm trying to, if missiles come in at me, I got a little counter missile, I need to know how quick that thing is going right now, not over 3 seconds. No, I need to know it's instantaneous velocity so I can calculate my trajectories. You guys kind of with me? All right, I'm not saying we're gonna have to defend the school. Did they tell you little tourists, well, I have to go out and defend the school for attack by Queen? Okay. No. So here's what we do. The only method we know to find a slope requires 2 points. We went into the slope at that point. So what could we possibly do? Come up with a second point. So so that's really nice that you said that without any prompting. That kicked so much ass. So here's the point I want to know the slope at, yes? If I pick another point, another input I should say, because we don't have a point yet. Here's this point, it would be f of x, and this one would be f of x plus h. Is that cool? I call it x plus h because now you can tell me exactly how far apart these two inputs are. How far apart are these two inputs? If this is x and this is x plus h, they are h apart. Okay. Can algebra find a slope now? Can somebody give me 1 point that's on that graph? Just from what I've told, I haven't given you any numbers, correct? So what's this point right here? X, f of x. Write that down.
Oh, I get it now.
What's the other point? X plus h? F of x plus h, yes? That's just glorified x1, y1, x2, y2, correct? That's specific x's and specific y's, but it's just basically it's x1, y1, x2, y2, yes? All right, calculate the slope. I'll wait. I recommend you do the bigger one first. We'll see what you think about that. It doesn't really matter, but it's there. It's exactly the same work you would do if I said calculate the slope between 1, 3 and 4, negative 2. The exact work you would do for that is exactly what you do for this. But is it going to look weirder? Hell yeah. Are you going to be able to tell me the answer is 7 or something? Hell no. Slope is y2 minus y1 over x2 minus x1. Rise y's, run other one. So if I treat this one, the bigger one, as the second one, that's y2 minus y1 over x2 minus x1. Is that cool? And what's the one thing I can immediately do? X is canceled. Now, some of you guys have actually worked with this before. Some of you have never seen it before. Do some of you guys remember seeing this? Okay, so it really depends on your pre-calc teacher or whatever you took before this. They didn't have to show you this. They didn't have to. So if you never saw it before, you're fine. How do I make this estimate better? Because this is an estimate, are you with me? So like, the slope I'm gonna get is this. Is that cool? Is that the slope at this point? Does that look like how I'm moving at that point? No, of course it's a little less steep because the point I picked was further on when I'm more over the hump, yes? How do I make my estimate better?
Make it smaller.
Make h smaller. Yes? Okay, I like it. What do I want h to be to get the exact answer?
0.
What happens if h is 0 though?
Undefined.
Undefined. Okay, so now, how's everybody doing so far? Does everybody understand everything up until the last thing I said? So now we have the motivation to investigate a process that lets us do what we want. We know we can't let h be 0. You guys all see that? Because then, of course, I mean, it's been rammed down your throat. You can't divide by 0. In calculus, we're going to be a lot more specific about that. There are cases and applications where we can do something like divided by 0, Little caveat. Okay. So what I want to do is I want to keep picking newer and newer inputs and get slowly closer to this. So why is algebra happy if I do that? Because it needs 2 points. And I'm always giving it 2 points. Why is calculus getting happier and happier? It wants 1 point, and we're slowly kind of merging the 2 points, yes? Does this point ever become that? No. Does it get as close as possible? Is that what I want to do? Yes. Do any of us know how to do that? No. Some of you guys might, because you might have had a little bit of calculus before, but so. Now I've laid the groundwork. I understand now that what I want to do is I want to let h get really small, but not let it become 0. We do not currently have a way to do that. Okay. So this problem here, this slope problem, we're going to set it aside for a moment. And we're going to develop the tool that we need to analyze it. So, what I want to create, let me just put it down here. Yeah, some of you guys might have seen this before. The thing that we're going to work with is called the limit. So what I'm going to do for a chunk of time before we come back to the slope idea is just develop the limit, because the limit exists by itself. It's got other uses. One place we can use it is to help us get the slope at a point. But the way the book says this stuff, it makes it sound as if limits are just used for, they're used for a lot of shit. That's just one reason they're used. Okay. Some of you guys might have seen the limit in pre-calculus. So I'm going to take a little side note about pre-calc. This is related to something we talked about earlier. Horizontal asymptotes. Can anyone remember what the horizontal asymptote would be for this? Yes, 1/2, exactly. Why? What's the degrees? They're both 1. So when the degrees are the same, it's the ratio of the coefficients. Does that sound familiar to anybody? So horizontal asymptotes are what happens when x gets really big. Yes? Okay. So some of your pre-calc teachers could have shown you this. Has anyone ever seen that notation before? Some of you guys. If you've never seen it, you're fine. You don't have to have. Just some teachers kind of sneak that in. The way to read this is the limit as the inputs, as x goes to infinity, is 1/2 for this. So as my inputs get bigger and bigger, my outputs approach 1/2. So if I were to graph this, I would put a dotted line at 1/2, and my function would eventually approach it. Who's got a calculator at the ready? Okay. Can you figure out? Let's test this out. How would I test this out? How would I test this out to see if it makes sense? What are we letting x do? What are we letting x do? Which, another way to say it is we're letting it get big. So can you please, let's put in there 10,000. Can you put 10,000 in here and just be really careful? You gotta tell the calculator doesn't have eyeballs, so it has no idea it's a big division bar. So if I wanna let this be 10,000, I'd have to put in the calculator like this. Or you could actually just, figure it out in your head and put those in there, but. Is everybody with me on what's happening? I should do it with you guys. Let's see. Do that. By the way, I really like to do what I'm doing right now. I talk a lot about concept, and then I have like a handout and so forth that's got all these very nuts and bolts. How the hell do I actually do the problem, Jeff? Dear God. So you need to get used to that. I'm going to talk about ideas, and then I'm going to have like a handout that shows you how you're actually going to do the homework. You with me? But I'm hoping if I talk about ideas, the actual work you have to do makes more sense. So right now, let's see, 10,000 minus 2 divided by 2 times 10,000 plus 5. There's enough zeros everywhere, yes? Okay. So I get 0.499775, which is almost what? 0.5, which is 1/2. So if you put in there 100,000 and a million, what do you think is going to happen? It's going to get even closer and even closer. Do you guys see how I couldn't even do this. I can't put infinity in. Dear God, don't write infinity minus 2. Because what I'm going to want you to do is to bring infinity to me. Put it in a briefcase, and I think that's what was in the briefcase in Pulp Fiction. Bring it to me. I'll open it. There'll be a glow. I'll close it and I'll go, holy shit. I don't know if you guys are with me. Don't plug infinity in, because then you're claiming that you can get infinity and put it in there. You can't do that shit. Yes? So I never let X become the thing I'm trying to investigate. I just get closer and closer to it. The only way that we humans can. Make a bigger number. Yes? Okay, maybe? Okay. So, let me keep myself on track. Good, yes, okay. So that kind of leads to an algebraic way to investigate limits. Let me talk about a graphical way to investigate limits. Let's see. Oh yeah. You don't have to make sound effects when you draw it, but you can if you want to. Really quickly, is that a function?
Yes.
Why? Passive regardless. If I would have filled that circle in, I would have to retire. I should stop. Okay. Because I can't have 2 outputs for the 1 input. Okay. This is obviously piecewise. It's fine in pieces. Are you with me? There are definite locations of weird shit. Where's some weird shit happening?
All discontinuities.
Now you're getting way ahead of me. Can't believe you, Mr. Person. All right. Be less specific. At what x values do weird things happen? At x equals -1, something weird happens, and at x equals 2, something weird happens. Yes? It's kind of almost the same weirdness, but not really. There's definitely a distinction between the two, yes? So let me ask you this. Here's where this is where things get weird. You have to be on top of your brain to look at this correctly. I want to investigate, for example, what is the limit as x goes to 2 of the function? Sorry. I always teach near a class that's teaching interior design.
That's interior design.
No, I'm joking. Sorry. The couch is in there and they move around. It does sound like it.
So loud.
Have you guys ever seen the movie The Blob? I haven't talked about that, have I? Okay, good. And I'm talking about the 1980s one, back when we knew how to make movies. The beginning of the movie, something crash lands. There's this guy, he's walking along, he's like, what is that? So you or me, we see something crash and it breaks open, we're gonna go, what is that? Let me see, right? I might not get very close because I'm like, it might be radioactive. I don't have my Geiger counter. It's a shot, right? What this guy did was he was like, what is that? Ooh, look at that ooze. And then he touched the damn thing. You with me? So he got to it. He allowed himself to become that, right in that thing's presence. So he allowed his inputs to become equal to it. Does that make any sense? We would do this. We would go, oh, okay. I'm gonna touch the damn. Are you kidding me? What is this thing? All right, that's what I did when I was like 3, and I was like, oh, what is this? It's a jellyfish. Oh shit! Just thinking that. All right. So the limit never gets to the number it's approaching. The limit not only doesn't give a shit about what's happening at 2, it has no way of knowing what's happening at 2. I am not allowing it to get to 2. Does what I just said make sense? And why does it go along with what we said earlier? We take the limit as h goes to 0 to try to make the points become the same. And I can't let h be 0. That's what the limit's purpose of existing is. It allows us to get as close as possible to something without actually getting there. Because getting there tears the fabric of the universe. So let's not do that. Okay. Or the thing jumps in my arm and eats me and the movie happens. Okay. So, do you see how there's 2 ways to approach this point? This input? Yes? I can come at it from this way and I can come at it from that way, yes? You guys see that? Yeah. Okay. As I approach from the right. So here's the right way to look at this. As my inputs get closer to 2 from this side, what do my outputs do? What are my outputs doing as you get closer and closer to an input of 2? What are my outputs approaching? 2. Some of you guys might realize it's where the freaking open circle is. It's at 2, right? You got to be a little careful over here, though. You might be, but so as my inputs approach the road I'm on, as my position here on the x-axis gets closer to 2, I'm approaching this pothole at 2. Yes. So the limit of the function as x goes to 2 is 2. Oh, and I got to be careful. The limit as I approach it from the right is 2. What's the limit as I approach it from the left? So if I come from this side, what are my outputs doing? Approaching what output? 2. Therefore, if you're in this car and I'm in this car, do we both agree on where we're going? Do we get there? Hopefully not, because, I grew up in Florida. The ground doesn't go up, it actually goes down. If you're driving, you could suddenly just be in a sinkhole. That just added extra excitement to driving. So we're both approaching the exact same location. So therefore, since we agree, the limit as I go to 2, period, is 2. So if you see a little plus or minus, that means specifically from one side or the other. If you don't see a plus or minus, it actually means to both sides agree. So you can automatically see what's happening at -1, yes? Let's see. Well, actually, before I leave, what is f of 2, though?
3.
Good. F of 2 is actually 3. Somehow we're in a car and we teleported there, which is neat. So if I give you a graph, I'm hoping you guys can see it's not going to be that hard to kind of follow and answer my questions. If I put a little plus sign, you're coming from the right. If I put a little negative sign, you're coming from the left. If I don't put either one, you're like, do they agree? So tell me this. The limit as x goes to -1. Does it exist? Do they both, from both sides, do they both agree on where they're going? So let's break this down. So we already know it doesn't exist, but let's break it down. What's the limit as you go to -1 from the right? So again, if I keep putting inputs and I approach -1 from the right, you guys with me? So as I approach -1 from the right, what are my outputs doing? They're getting closer to -1. Do you see how easy it is to visually get confused with the question and what you're supposed to be analyzing? So you gotta constantly keep on top of yourself because you're not used to doing this weird shit. So can you guys see? You already know what I'm gonna ask you next, right? The limit as x goes to -1 from the left side. What would that be? As I put inputs and approach -1 from the left side, what are my outputs approaching? +1. So if we're driving in this car and you're driving in that car, then we ain't gonna see each other. You're staring in a hole and I'm staring at the end of my road. I'm like, oh. So what's the limit as x goes to -1? Does it exist? Why not?
Is there two?
They don't agree. So you just say does not exist. Let me stop for a moment, not forever. How you guys feel so far? So limits have the overriding idea of the limit as x goes to point, I'm trying to get close to that point. So visually, we do that. But then we bring in, I can approach a point in two directions. I can approach it from this way or that way. And if any of you guys are going to take Calc 3, you're going to have a lot of fun because then you're in 3 dimensions and you can approach a point in a lot of different ways. So let's just appreciate that we sliced 2D for this class, yes? So we can only approach a point in 2 ways. Oh. That's good for that, yeah, and that's good for that. And then we'll get there, beautiful. So let me do this. I am going to shut up, and I'm gonna let you guys, there's 2 sides to this. I want to do the side with the red graph. Yes? Okay, do all the problems on the red graph side. And by the way, if you get homework done, just put it right here in the corner of the table. When you come in, when you leave, whenever. Right there. And I'll have a little tear come out. I'm so happy that you did homework before the day of the test. Okay. So guys, this might help. Let's see. All right. This first question says, as I approach -4 from the left. So let's see. If I if I input like this input here, that output is roughly 1. Do you see that? So for that input, the output's 1. If I put this input in, the output is roughly 1.5, maybe. You guys see that? If I get really close to it, the output's just below 2, maybe 1.9. So what are those outputs approaching? 2. That's it. That's all we're doing. So as I move towards -4 on the x-axis, when I look up, what are my outputs doing? They're approaching 2. What about from the other side? Same thing. They're just coming from above down to 2. They're still approaching 2 though. This says, does the function ever actually get there? I'm sorry, this one does. This one says, do these agree? Yes. So does it matter what side? Can I just leave a plus or minus off and you can just tell me what the answer is? Yes. Does that make sense? That's why they have to agree, and I can just go, it doesn't matter what side you come from, it's 2. This one only cares about right at -4. What's the output? Is there an output? So yeah, undefined is a preferable way to say that, but if you put does not exist, that's fine. How are we doing so far? Does that make more sense? Okay. It's almost like something's got to click in your head to look at this right. And that's the hardest part about math, is when things just have to kind of click. So this one wants you, put your glasses on, Jeff. Oh. This one wants you to go to 1 from the left. So here's 1. So as I approach 1 from the left and I look at my outputs, what are my outputs getting closer to? 4. My outputs start above 4 there and then they come back down to 4. What about from the right? If I put out my inputs and I let them get closer to 1, what are my outputs doing?
-2.
Closer and closer to -2. Can I just take the plus or minus off and you know what it is? No, it depends. So therefore, does the limit just exist outright? No, it does not exist. But at 1, what's the function actually doing? Landing on 1. Now, real quick, if I would have filled this circle in instead of that circle, then the f of 1 would have been -2, yes? So the output for a limit at an input does not have to be in any way related to the function value there. I always think of it like there's a pothole, they come out to fill it, but they miss filling it. So like this situation here, do you see how there's a pothole? They came out to fill it and they put it in the grass next to the road. Right? You can see that. It's like, good job, tax dollars, yay, okay. And then of course, this one, 6 from below, what are my outputs approaching? My outputs are approaching 5. They're way up here, right? My outputs are going up and up and up, and they're approaching 5. If I ask you what f of 6 is, over here, what's the output for input of 6? The output is 2. So I told one student, I think I said it kind of loud, so some of you guys must have heard me. This only cares about what it is right at that input. It has no idea how it got there. This only cares about where it's going. It has no idea if it gets there. Do you see how the two of them together give you a complete picture? Okay, so that's going to come later with continuity. And of course, if I go from above, what happens? What are my outputs approaching? 5. So therefore, does it matter if I put a plus or minus? They agree, so that's 5. I like it. If the crew would have come out, if they would have put that filler, if they would have put it in the hole, would they have removed the problem? Yeah. So just to give you a little preview, we call that a removable discontinuity. It's a little preview. It makes sense that part of the word is removable, because if they would have just filled the damn thing in the right place, it would have removed the problem in the road. Do you all agree with me? If I'm traveling this road, is there going to be a problem for me here? Yeah. Oh, how's it going? You know, no good. Okay. All right. Don't worry about continuity. Just a little preview. That word actually makes sense. It's amazing. Okay. What about this one? I don't know if everybody had a calculator. You could always ask me to borrow one. I've got some. So if I do natural log of 0.9 divided by parentheses 0.9 minus 1, I get 1.0536. Is that what you guys got? And then if I just do second enter and I just put 0.99 and 0.99, I get 1.00503, blah, blah, blah.
Can we just look for the horizontal aspect?
And my 0.999.999, I get 1.0005. Okay. So you can pretty much already make a guess. Do you understand why I have the other two inputs? How does that relate to what we just did up here? Because what is this asking me for? The limit as x goes to 1. So if I want to investigate that, don't I have to approach it from both sides? I have to put inputs bigger than 1 and inputs smaller than 1. So right now you'd say your guess is 1, but what if you did these and they were like -1.3, -1.01? These wouldn't match then. They wouldn't come together. Does not exist. Do you guys understand what I'm saying? You have to investigate both sides if it doesn't say one side or the other. So let's see. If I plug in there, what did I just say? 1.01. You can do it, Jeff. 01 and 1.01. I get 0.995. And if I put 1.1 in there, no, Jeff. Bam. Bam, bam. 0.953. So if I look like this, see that? If I look like that, they both look like they're going to 1. Could we be wrong? Could we be wrong?
We could, but unlikely.
We totally could be wrong, but we feel pretty good. I really want you guys to understand, the work we've done is good for an estimate. Couldn't the answer actually be 1.0000000000029?
Yes, it could be any arbitrary value, but that's not the point.
Exactly. So these problems, we're taking our best guess. We're only humans. We're trying to see the pattern. We could be wrong. But I feel pretty good about that, right? Okay. On the graph, what does this mean? What would happen on the graph of this thing? If I graph this function, can anyone tell from what we've done what you would expect to see? At an input of 1, what would I have to put there? An open circle. You guys with me? In fact, let's try it. One of the best things ever, and oh shit, well, Jeff not logging into the damn computer is now one of the best things. All right, did you remember? Let's see how long it takes. You guys know about Desmos, yes?
Yes.
Anyone never heard of Desmos? Okay.
Desmos is great, but I prefer Wolfram, I'll be honest.
I understand, but Wolfram, Desmos is silly, the amount of stuff it could do, to be honest. Wolfram does more stuff, sure.
Mm-hmm.
But this is, if you just care about graphing,
Desmos is better for just
I would
graphing,
do this.
I agree.
Let you drag the different colors.
Is that right? Okay. Now watch this. Do you see how it tells me the input and the output? Can you guys all see that? So watch what happens when I get to 1. Let's see if I can do it.
Well, there's definitely something there.
There! Okay. Do you guys see that? It says 1, comma, undefined. So that's an open circle, right? Okay, maybe. Maybe. Okay, so that kind of ties in with what we're doing. The limit is 1. The limit is 1. There's no question. In fact, you can see as you get closer, let's look, my outputs are 0.9, 0.92, 0.94, like we just saw with what we did. On the other side, it's 1.03, 1.01, blah, 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 blah. It's approaching 1. Okay, we stop. Later this semester, we'll learn something called L'Hopital's rule. If you try to use that before we learn it, you're losing all the points. So be really careful. The tutors, if you go to ask them about a limit question, they have to remember this early in the semester, you guys don't know this thing yet. Because it's based on some calculus stuff we have not talked about yet. You guys kind of with me? So it's not your fault if they show you this and you didn't realize it was not good. But make sure if you're asking a limit question, go, is that L'Hopital? We're not allowed to use L'Hopital yet. We don't know about it. You with me? If you think about it.
Don't use what?
It's a French mathematician. His name's L'Hopital.
Right.
Like the hospital, basically. So every time you say that, it turns over in his grave. Unless it was cremated, in which case a little bit of earth kind of goes up.
Yeah, I'm just trying to figure out what you meant by like a specific.
It's a process we named after him because he came up with it.
Right. So just don't use that.
Not yet, because we don't know how it works yet.
So just when advised to use this formula, just figure out
Just
a
tell
way.
them, no, crazy person. We're not allowed to do that. Okay. So, before we look at the back, I have to talk about how to do it. I got to keep it on the time too. It's over here.
Oh no.
Okay. So here's oh shit. No, I'll try doing it. Here's some exciting stuff. What do you guys think? When do I really have to be careful about limits? Well, let me go back to this actually. Here. I'm very sorry for this. I'm coming up with an example on the fly. Do you guys see every question I asked here was about the trouble spots? Do you agree? What if I ask you, what's the limit? Is there a decent point here? Nah. Oh, almost. All right, let's pretend like this is way down there. You with me? What if I said, what's the limit as x goes to 2? Do you see how that's, you don't even have to think about it? Why? Is there a problem at that point? No, it goes through it, the limits agree, and the function gets there, correct? You guys with me? So, let me ask you this. What is the limit as x goes to 1 of x plus 3? Say it.
4.
4. Does x plus 3 have a problem somewhere? You know what I mean? Like 1 over x minus 1 has a problem somewhere, yes? X can't be 1, are you with me? Because then it would be division by 0. X plus 3. Is there any number I try to add to 3 and it freaks out? No, not a real number. Don't give me some. Try to add square root of negatives to show. Real numbers. If you want complex, I can do it. You do everything complex. Does anyone want that? All right, cool. Okay. So it's always real numbers unless they say otherwise. So is everybody cool with the fact that that's just 4? I don't have to do any crazy work. Why can I just plug a 1 in? Because it has no problem there. The output is exactly what the limit would be because it just goes through it. There's no issue there. Are you guys semi with me?
I don't see how you got 4.
What happens as you get closer to 1? What is the output of x plus 3 if you let x get close to 1? 4. Yeah. So if the function has no issue, I could just plug it in. Yes? And that's why we normally, again, did I say anything about any, like, -2? Did they care about -2? Did I ask you about limit as x goes to -2? Why not? Because it's kind of boring. But it's very good to point out, what is the limit as x goes to -2? It looks to be about 4, yes? I don't have to do any work. I don't have to be careful. Why? It had no issue there. The function is defined. It goes there. It gets there. Okay. So what is the limit as x goes to -3 of the square root of -2x plus 3? What do you try? What do you think you try first? What did we do here? How did you guys get 4?
Plug in
You plugged a 1 in, and then you step back to see, does it have an issue? No. Okay, there you go. I know what it is. I know the answer's 4. What do you try then here? Plug in -3. What's -2 times -3? 6 plus 3. Square root of 9 plus 3. So if the function has no issue at the input, we don't need any help. We did that shit back in algebra. Yes? Are you guys kind of with me? If I gave you a function graph and I said, what's up to 3, and it's a graph like this, it has no issues, you could just see it. The output is this. That's what this is all about here. I could just plug a -3 and I could see the answer. So let me show you an example of one you can't just do that with. What about this? Does this have an issue? What's the immediate issue you guys picked up on?
0 on the bottom.
0 on the bottom. What is the top though? What's the top at 2? 0. Okay, now listen, this is where we're going to get really fascinating. What is 0 divided by anything? 0. What is anything divided by 0? Undefined or infinite, yes? So what is 0 divided by 0?
1.
It is somehow 0 and infinity at the same time. Sometimes it could lead to 1. But to be honest, it could be anything between 0 and infinity. I need you to understand. 0 over 0 sucks. Something over 0 is fine. 1 over x squared. As x goes to 0, that's infinity. 1 divided by really, really small positive number is a really, really big positive number, correct? Okay. So the bottom going to 0 is actually fine. Some kind of infinity. If both the top and the bottom go to 0, that is worse than undefined. That is called indeterminate. I cannot determine the answer. Could be anything between 0 and infinity. To be honest, it could be negative even too. So, what the shit do I do then? So, can you, I kind of wrap this into one thing. Can you simplify the fractional expression that I put in there? The rational expression. Can you simplify this? Please, dear God, Nobody tell me you can divide, you can cancel an x. Why can't you do that shit? Good. Division can't cancel parts of an addition subtraction problem. That's not his job. Yes? So what do you have to do instead? Factor. Does anyone remember how to factor this thing? So let me do this. Let's focus on this expression for a minute. We're going to come back to him in a minute. Does anyone remember how to factor a cubic? Little dude, big dude. What is x cubed if you broke it all the way down? X times x times x. And what's 8? 2 times 2 times 2. I love it. Look at this. It's a little dude. It's a little dude. So I'm gonna put one of each thing because he's a little dude. I'm gonna put one x in there, which means I'm gonna put the other 2 x's there. If I started a FOIL, do I get x cubed? Okay. I'm gonna make the same sign. So I put one x in there. I'm gonna put 1 2 in there. So I'm gonna put the other 2 2's over here. Do I get minus 8? Yes. Does this sound familiar to anybody? So remember? Okay. Just to really show you. So I get x cubed. I get minus 8. Why don't I just stop? Math boy. Stop. Because I also get frickin' minus 2x squared. You guys agree? Minus 2x squared. Did I want to get minus 2x squared? Nope. And I also get freaking 4x. Yes? So I'll cut to the chase a little bit. I normally talk about Pulp Fiction. Anybody ever seen Pulp Fiction? Yes, you've seen it. Anybody else? It's not a prerequisite for the class, but there's a scene where a terrible thing happens in the back seat of his car, and they have to call this guy the cleaner. His name was the Wolf. His job is to clean the shit up that you don't want. And there's a lot of stuff in the back seat they did not want in the back seat. Okay. You don't have to watch the movie ever. In fact, if you're any queasy at all, maybe you should. Excellent movie though. I need this middle guy to be the thing that kills this shit I don't want. It cleans it up. So can somebody tell me, wouldn't it be great if I had a minus 4x? Do you see how that would kill this? What would I put here so that negative 2 times this would be minus 4x? Plus 2x. So negative 2 times 2x is minus 4x. Die. Notice something remarkably cool. What is x times 2x? X times 2x. Positive 2x squared kills that. So watch. When you have a cubes, 1 of each, 2 of each, product 2 times x in the middle. And what do you use to clean things up normally? Soap. This is the same sign. This is the opposite sign, and this one is always positive. Yes? Okay. Maybe? Screw you, Jeff. Okay. So this is just a factoring method. This is the factoring method that students like the least because you have to kind of memorize how to put it together. But it's 1, so x cubed, how many x's are there? 3. 8, how many 2's are there? 3, yes? 3 2's, 2 times 2 times 2, yes? So 1x there, the other 2 have to go there. 1 2 there, the other 2 have to go there. This guy just cleans the parts I don't want, that's it. Real quick, remind me, how do I factor x squared minus 49? X plus 7, x minus 7. Why'd you do that? Because how many x's do you have? How many 7's do you have? So you put 1 there, it makes 2. You put 1 7 there, 1 7 there, it makes 2. Yes? Plus minus, it cleans itself. This one, it's got extra shit happening. It needed some help to clean the shit it didn't want. Yes? Maybe? No? Screw you, Jeff? Okay. Yes?
So isn't there a formula for that? It's like, isn't it A minus B?
Yeah, if you like this for some reason, which is fine. I just never understand why this is preferable. That's the formula for it.
And then if it was A cubed plus B cubed.
Yeah, this is plus, this would be a plus, and this would be a minus. So this is the same sign. It was a minus, right? So this is the same sign. This is the opposite of that, and this one's always positive. If this helps you for some reason, great. But you see how there's 3 A's, 1 A there, and 2 A's there. 3 B's, 1 B there, 2 B's there. The middle is the product of these two. 1 of each, 2 of each, product in the middle. That's the closest to a song. You're gonna get me. Ba, ba, ba. Okay. I do have one more song for calculus and you'll love it, so I'll tell you when we get there. Okay. So that was the top, correct? Let me write this again. And on the bottom was x minus 2, correct? Can you guys see what happens? Yes. Now, let me ask you this. You guys agree x minus 2 cancels? There is one time when that is not true. What value of x, it's very easy, what value of x would make that not true? That I can't cancel those? 2. So if I try to plug a 2 into this, it won't work. This function is equal to this function always except if x is 2. Does everybody get that? Didn't I start with this and I just simplify the damn thing? So of course this equals this, unless x is 2. Because then this is 0 over 0, and we already talked about how that is freaky as shit. So as long as x is not 2, this function is the same as this. Is everybody with me? Let's try it real quick. What's 3 cubed? Let me put this down here. All right, so what is 3 cubed? So this would be 27 minus 8 over 1, which is 19. Is that cool? So if x is 3, this function is, output is 19. If x is 3, what's this guy's output? $19. Okay, so as long as the x input is not 2, this is equivalent to this. So what's nice about the question I was analyzing here? What is nice about that in terms of x being 2? I'm applying a what? I'm applying a limit. What's the whole idea of a limit? It will never be, x will never be 2. I'm just going to get close to 2. I really want you guys to get this. Do you guys see what I'm saying? So the only time I can't replace this with this is if I'm using 2. And is this ever allowed to use 2? No. So then I can rewrite. Now this is where things get a little trippy. You got to kind of trust me. I can take this question, just to really show you everything we just did. I can simplify it down. And now, what I have left, does it have an issue with 2?
No.
So then I can plug it to it. So now if I graphed on Desmos, if I graph this, at 2, it would say undefined. There would be an open circle at 2 comma 12. There would be an open circle. So look at what's beautiful here. The only way a function can have a problem at 2 is if it's got 0 over 0, if it's indeterminate. What did we do? If the problem was the fact that the top was 0 and the bottom was 0 at 2, look, this is awesome. We killed the problem. Not a life lesson. If you have a problem, don't care what it is, don't kill it. Okay. But here in math, these guys don't kill anything, you're fine. So we kill that, we killed the problem. Now can I evaluate the limit? Yes. So this is the algebraic evaluation of a limit. If I can simplify the function I'm dealing with, I can maybe kill the problem. Get rid of the part that's not letting me plug a 2 in, or whatever it is, and then I can plug it in. It's almost too nice to believe. Okay. So what does this mean? You gotta know how to factor. Those are gonna be problems, yeah. But cubes are normally the least appreciated factoring forms. Squares you should be all over, yes, for example. What about this kind of problem? Oh geez, I'm gonna try to make one out of nowhere. Okay, this should be exciting. Everybody calm down. Shit, Let's see if I can do this. Can you do it, Jeff? I don't know. Oh yeah, okay, that'll work. Well, if I just do this, it's fine. I think that's even on the warm-up sheet. Okay. So we already did this, and now you kind of see why we did this. Do you guys remember how I did this? I think the warm-up sheet actually had it on the bottom, but it doesn't matter. Let me show you. Do you guys see how, is that indeterminate? What does indeterminate mean for us right now? If I try to plug it in, I get 0 over 0. Is that indeterminate? Yes, if I try to plug a 1 in, I get 0 over 0. Dear God, by the way, do you guys see how that -1 is not inside? Just take a moment. There's a student had a really good, this should have been the symbol of a square root. They should have like a back wall. Okay. So do you guys remember how we deal with this? And multiply by the conjugate, remember that? So this is indeterminate, yes? That is in the form 0 over 0. Which means I want to attempt an algebraic simplification. Because then maybe I can kill the problem. There's something not allowing me to put a 1 in. Let me go kill it so I can put a 1 in. Here, I'll do the bottom. You get this times this. Whew. Okay, what do you guys get on the top? What's root x times root x?
X.
X. And the middle terms cancel, yes? And then what's 1 times 1? Bullshit. And then what happens?
Then you get to get rid of.
Now be really careful. What's left?
Square root x plus
Where is it?
on the bottom.
Beautiful.
1 over.
Can I plug a 1 in now?
Yes.
I eliminated the reason I couldn't plug a 1 in. I can now plug a 1 in. And of course, what do we get when we plug 1 in? So again, there would be an open circle at 1 comma 1/2 if I try to graph the original function. Okay. There are even more of you that I never want to play poker with. How are you guys doing? Are you guys doing okay? So you start to realize graphical interpretation of limits. I really hope that thing we did earlier is not that hard. It does take a little bit of, you gotta really keep on yourself in terms of how to look at it correctly. Algebraic evaluations of limits. You have to remember how to factor. You have to remember conjugates. Yes, that kind of thing? Okay. So let's do this. On the other side of the handout are these 3 here. Do those. And don't, all right, let me say this right now. Let me tell you this right now. You ready? I'm going to tell you a kind of problem I'm going to put on the test, on the quiz, whatever. You ready? Students always want to know this. I'm going to put a problem like this. And I get students that are like, let me see, how do I factor this? I can't factor this. What are you doing? I can't. I'm going to try to, maybe I got to use quadratic formula. Oh, wait, no. What do you do first? Plug a 2 in.
Plug the 2.
What do you get when you plug a 2 in?
0 on top and 3.
2 squared? 2 squared is 4 plus 3 is? Is that indeterminate? No. In fact, it's totally determined. Can you determine the answer? Yeah. I'm always going to put at least one problem where you don't have to do shit in terms of algebra. You just plug the damn number in. So if people just start doing algebra, I'm like, no, you only do that if it's indeterminate. If it's not indeterminate, that literally means you can determine the answer right now. That was not indeterminate, I'm done. Now I think all 3 of these, you actually have to do shit too. But I just want to make that point. Okay. If I remember correctly, let me see. Yes.
I think. No, C, right?
No, this will be 1/4 minus 1/4 over 4 minus 4. 0 over 0.
Yep.
hint on part A, you wanna do GCF first. It might get a little trippy if you don't. So guys, in the interest of time, let's go over these, because then we're gonna take a little tour. So listen, for these limit questions, oh shit. That might be easier if you see what I'm doing. For the limit questions, I gave you 3 of the most classic limit problems. Factoring, conjugate, like denominators, yes? Or you can call it fracception, fractions inside of fractions, yes? Those are the 3 main kinds of limits that you have to do algebraic manipulation to. But what is it you do, of course, before you start doing any algebra? Check it in. So if you plug the 3 in, you get 0 over 0. And that means, oh shit, I gotta do something. Damn it. So then, factor out a GCF, Jeff. And then, break this up. So at no point yet can I plug a 3 in, you agree? But what can I do now?
Is that x minus 3?
And now I'm allowed to plug a 3 in to what's here. And what do I get when I plug a 3 in? Huh? 24. So the x minus 3 is canceled, yes? What's 4 times x plus 3? 4x plus 12. When you plug a 3 in, you get 12 plus 12, 24. Okay. Now, I'm trying to figure out how to say this. I will obviously help remind us of stuff. I have a lot of calculus to teach you, so I can't do an entire class on factoring. So if you have a lot of trouble with factoring, you want to come to the CISL, you want to come to office hours. There's handouts up on Canvas related to factoring, yes? You are going to have to do a little extra work on your side to catch up with some prerequisite skills, if you need to. I will help if you just reach out to me. Okay. If I see a radical involved in an addition subtraction problem, I think conjugate. But only if, when I try to plug that 0 in, I do get indeterminate, and I do. I get 0 over 0, right? So I immediately think, let me multiply by the exact same terms, just a different middle sign. That guarantees it's going to have a middle. The only place there could possibly be a radical left if I do this is in the middle. If I do it this way, the middle terms cancel. So I've killed all the radical pieces, right? I always think I'm like a tyrant of a country. I want to get my radical pieces and I want to kill them to restore order. Okay. Here's the mistake people make on the top. 3 times 3, well, that's one big mistake. And then minus, I've made a mistake. I've made a mistake. I have made a mistake. Is everybody cool with the square root of x plus 9 times the square root of x plus 9 is x plus 9? Half of x plus 9 times half of x plus 9 makes a whole x plus 9. The only mistake I made is I'm supposed to be subtracting it. That changes everything. Over 2x times bullshit. Never multiply that through. You'll see why here. What happens on the top now? If I distribute this, I get 9 minus x minus 9. The 9's cancel, yes? And then what else happens? What happens right now? The x is canceled. That was the crucial step, because that was the thing that was keeping me from plugging a 0 in. Can I plug a 0 in now? Yes, because the top is always -1. There's no way this could be indeterminate. So this would be -1 over twice 3 plus the square root of 9, which is 3. 3 plus 3 is 6, times 2 is 12. Kabam. Okay. So in the extreme interest of time, We're gonna finish this up next time. Everybody do a huge favor. I'm gonna make this tour very quick. Pack up all your stuff. Walk out of the room and start going that way very slowly. Let me run out in front of you, okay? Let's just do that much. Okay. Start chipping up.